variance and standard deviation. So far we've had range, which tells us the distance from the lowest one to the highest one, and we've had interquartile range, which tells us the middle 50%, what the range of that is. And that tells us how spread out our data is a little bit. But we're going to look at different ways of measuring the spread of data. So the variance combines all of your data points to give you a number that tells you how spread out the data is. Now, here is in words the definition of variance. So my question is, if you read, it is the arithmetic mean of the squared differences between each value and the mean value. So reading that sentence, if I gave you 5 numbers, could you find the variance? Or is that a pretty heavy sentence mathematically? Okay, so we're going to look at what that means, because if you read it again, okay, it's the arithmetic mean, that's your average, of the squared differences between each value and the mean value. So we'll do the actual math, and we'll look at that sentence again, and then be like, oh, I can see it a little bit better now. And then the standard deviation, that's just the square root of the variance. Has the same units as the data. So we're going to look at an example. Here's 2 tests. Both tests were out of 20 marks. Okay? I want you to put test 1 into list 1 and test 2 into list 2 in your calculator. And I want you to calculate the mean, median, mode, and range for both of them. And were you able to get mean, median, and mode from your calculator? And so the interesting thing about these 2 tests, if someone said, what was your average? You'd say 13.5. What was your mean? Well, what was your average? 13. What was your median? 13.5. What score happened the most? 14. It's the same for both of them. And the only thing we have different is one has a bigger range than the other. But that just tells you the difference between your lowest score and your highest score. Does that mean both classes are the same in the middle? Or are there significant differences? No, maybe you just, yeah, it should be 13.5. So, yeah, so that's also off a little bit. It should be exactly 13. There might be one number you added in wrong. If we put the data into frequency tables, we can see a little bit more. We can see that that test 1 is really spread out, and that test 2 has a lot more people clumped together. So we would say that the marks vary more on that first test than the second test. So one of the things that your calculator also tells you is your standard deviation. So on the first one, if you have your data from your first one, can you tell me the number that you got for sigma there and the number you got for sigma on the second one? You have one? Which one do you have? The first one or the second one? And what did he get? I'll just go 4.387. I'll round it. There we go. Practice my squiggle brackets. 4.387. I'll round it 4.39 to 3 sig figs. Someone with the second one? $1.76. 1.77 when rounded. Okay. So we have our standard deviations there. And we're going to learn that this actually tells us a lot about the information. This standard deviation of 4.39 marks, that tells me that about 68% of the people should be 4 marks above and 4 marks below the mean. So the mean was 13. If I go up 4, that goes up to 17. If I go down 4, that goes down to 9. In that one, about 70% of the people are between 9 and 17 marks. But in this one, with a standard deviation being close to 2, I have about 70% of people between 11 and 15. And so we're going to learn how to use these standard deviations and what they mean and how they can tell us more information about the data. It can tell me I know where 95% of people are in my class based on those numbers. Whereas my range just tells me my maximum to my minimum. I don't know how the data is spread out within there. And of course, on your calculator, if you wanted to find your variance is just this number squared. Okay. Here's test number 1. If we wanted to calculate the standard deviation by hand, and if we wanted to calculate the variance by hand, we have each of these scores from 5 to 20. And their frequency listed here. If we look at, okay, this is our score minus our mean. We already know that our mean was 13. So if you took 5 minus 13, you would get negative 8. 6 minus 13, negative 7, and so on. You then square this answer, gives you all positive answers. And the reason we square them is because in the end, we're going to want to add them all up. Okay? This last one, you see how the 36 changed to a 72? Because we had 2 of the score 7. The 9 changed to an 18 because we had 2 of that score. The 25 changed to a 75 because we had 3 of that score. And in the end, if we add all of those things up, we get 616. The reason they get squared is because something that is 8 above the mean is the same distance away from the mean as something 8 below the mean. But if we considered one being plus 8 and the other one being minus 8 and added them together, they cancel each other out. So squaring them makes them all positive numbers and gives us a total of 616. The bigger this number is, the farther stuff is away from your data, from your mean. Because bigger numbers, like the number 5 is 8 away from the mean. When that gets squared, it gets a big number like 64. The farther something is away from the mean, when you square it, it becomes even bigger. And so the larger this sum is, the more spread out our data is. We can check our mean. There was 416 things in total. Divide by 32 students gives us 13. Our formula for variance is just that total sum divided by how many we have. So that's 616 divided by 32. And then our standard deviation, which we got from our calculator, is just the square root of our variance, which is 4.39. So now I'm going to go back to our very first sentence, and then I'll come back to this in a second. It is the arithmetic mean, which is an average, which means you add something up and divide by how many you have, right? Of all the squared differences. So if we add up all of our squared differences, here's the squared differences, times by their frequencies, add all of those up, divide by 32, that will be our variance for this. So in this part, the squared differences, well, a difference means you subtract how far it is from the mean and your score, and it's squared, so that means you just have to multiply it by itself. Again, how tedious is it to do this by hand? Very tedious. So this unit in particular is highly calculator. You get to use your calculator to find all these things because it's way faster to get your answer from your calculator. That being said, there might be a question where it says, do you really understand where this comes from? Do you really understand, if I click here, do we understand what everything in that formula means? What it stands for, where it comes from? Because we might ask you a question that says, do they know what this Fi is? So if we look at this, okay, can you see that the x minus the mu, that's the difference between your score and the mean? And that's getting squared. Then each of those differences gets multiplied by your frequency. If something happened 5 times and it was a difference of 5, so squared would be 25, well, you'd have to add 25 5 times. Then you're finding your average, so you're dividing by how many you have. Once you've added these all up, this is your sum sign. You're finding your average, so you're dividing by how many you have. That gets your variance. And if you want to find your standard deviation is just the square root of the variance. Yes? F is the frequency, and the reason it has Fi, because you're looking at each one. This is my first one. It has a frequency of 1. F2 would be my second one. F3 would be my third one. So the little I is just indicating that you're checking first one, then second one, then third one, then fourth one, then fifth one. Okay, so we already figured that out, 1.77. So on your calculator, there are 2 standard deviations. The one with, oh, I've said it a couple times. Do you know what letter that is? Sigma. That's the little sigma, okay? Doesn't look like mom or dad at all, right? I don't know how that grows up to become that. You see a resemblance? Like, no. Yeah, I don't know. Okay, so there's big sigma and little sigma. Do we have any English letters that do that? Yeah. When you grow up, you're like, no.
Like a little Q doesn't look like big Q.
Yeah, little Q. There we go. I guess this happens. Those don't look at all alike. Yeah, G. So we do have it in English. We just make fun of it when it's in Greek a little bit more. Sigma. Yeah. You just wait. You're going to meet someone. Their name's going to be Sigma, and you're like, oh, I wish I would have never said that. Okay, so there is the sigma, which is our population standard deviation. We've already seen how that's calculated, and we will always use that one in this course. When you get to some advanced statistics in university, you're going to learn that the SX1 is your sample standard deviation. It's the same calculation, but you divide by n minus 1, and it gives you an estimate instead of the accurate one. It's when you're using a sample. But we don't deal with that in this course, just for interest's sake. Later on, when you're in university, when you see it, you'll get into the theory behind that. No, isn't that annoying? So, to save you time, boom, boom, I'll give you those. I'll let you calculate the rest. And then use your formula to find out standard deviation and variance. And check those numbers to see how you did. And then were you able to put them into your formulas? Find your mean, variance, and standard deviation. So some things to look at. If you had the same amount of people and you had a low standard deviation, on here the y-axis would represent our frequency. The middle, right here, would be our mean. Most of the data in a low standard deviation, you have higher frequencies because everything is close to your mean. But if you have the same amount of people and you have, if you have a low standard deviation, you have higher frequencies because everybody's close to the mean. And if you have a higher standard deviation, that means your data is more spread out. You have less frequencies of each one in order for that to happen. And what we have in the diagram here are some bell curves because they make the shape of bell. And those are a specific type of statistics that we're going to be looking at moving forward. Some properties of standard deviation. Standard deviation is never negative because you're looking at squared values and then square rooting. It's never negative. It is sensitive to outliers, right? If in this class we were trying to figure out standard deviation for height and we had someone in here that was 7'8", that would really throw things off. For data with approximately the same mean, the greater the spread, the greater the standard deviation. Does it make sense that if all values in a data set are the same, the standard deviation is 0? And here in particular, the IB likes to make you think about what happens to data if we do something. So what happens if there's constant change? If you took everybody here, okay, and over the next 10 minutes I made you eat No, I made you drink 5 kilograms of water. That's a lot. What would happen to each of your weights? You would each go up by 5 kilograms, pending any accidents. Spilt water is what I was meaning. Right? And so, what's going to happen is the spread is going to stay the same, but your average weight will go up. The average weight of the whole class will go up 5 kilograms, but the spread of the data will still stay the same. We'll just all be moved 5 kilograms heavier. Okay? Now, if we multiply each of you, okay, I get a special pill that allows each of you to double in size. Also very interesting. Great. Especially if we just did the water experiment earlier. Potential for accidents might go up. If you each doubled in size, okay, what's going to happen? Both the mean, right? Can it make sense that the average class average would be doubled as well? But the standard deviation, now the spread is going to be bigger. Because if you think of the smallest person weighing 100 pounds, now they're 200 pounds. The biggest person weighing 170 pounds, they're now 340 pounds. The spread has increased as well. And what's going to happen is that would be doubled as well. So now you have your first take-home quiz. We have 12 minutes left. This has finished the first chapter. If you look at the front right, this was chapter 8 in our textbook. We have finished chapter 8 in our textbook. So our first concept and statistics are done. So we have that take-home quiz, and you can spend the last 15 minutes getting a start on that.